Okay, let's dive right into this. Welcome to Lesson 2, Cables, Copper versus Fiber Optic. Now, you use Wi-Fi every single day, right? Whether you're gaming, doing homework, or streaming your favorite shows. But did you know the internet actually travels through millions of miles of cables buried deep under the ground and even right across the bottom of the ocean? It's true. Today, we are going to explore the two heavyweight champions of this hidden physical world, copper and fiber optic cables. So, I want you to imagine something for a second. How does a massive high-definition YouTube video actually get all the way to your phone? It is so easy to fall for the illusion that our data is just, magically floating around in the air. Because of Wi-Fi and 5G, we rarely see the wires anymore. But the reality? That wireless signal only travels a very, very short distance before it has to jump into a solid physical cable to make its epic journey across your city or even across the whole world. Just take a look at this familiar little device, your stay-at-home Wi-Fi router. You see those antennas? They're beaming wireless signals straight to your laptop or phone. But if you look closely at the back, see that blue wire plugged into it? That is where the magic really starts. That one wire connects your wireless bedroom directly to the physical, wired backbone of the entire planet. And when we talk about this physical backbone of the internet, we're really talking about two totally different ways of moving information. Since our data has to travel as energy, it basically has two main choices. It can travel as glowing, crackling electricity pulses, or it can travel as blindingly fast, straight-shooting beams of light. Electricity or light? These are the two main characters in our story today. Here's a quick look at how these two stack up. On one side, we have copper cables using those zigzagging electrical waves, and on the other, fiber optic cables using those lightning-fast, straight light pulses. Let's actually break down exactly how each of these works in the real world. First up, let's meet the old reliable, copper wire. You'll often hear this called an Ethernet cable. This is the exact cable you probably have plugged into your gaming console or family computer right now. Its absolute superpower is electricity. It sends your data as little electrical pulses, and it can actually carry a very respectable 10 gigabits of data per second. But there is a catch. It really only likes to travel short distances. It completely maxes out at around 100 meters before it just gets too tired. So, let's weigh the good and the bad of copper. Why do we still use it so much? Well, for starters, it is super cheap to buy. It's also incredibly flexible. You can bend it around corners, snake it under carpets, and it's just really easy to install in a house. But those glowing electric pulses definitely have their weaknesses. Like we just mentioned, the signal weakens over long distances. It literally runs out of juice and needs special devices called repeaters to boost it back up. Plus, because it's electrical, it's totally prone to electromagnetic interference. That means if you put it too close to thick walls or other buzzing electronics, the signal gets staticky and noisy, which instantly slows down your connection. Now, it is time to introduce our second character, the superhighway fiber optic cable. This is the futuristic stuff, guys. Instead of metal, these cables are made of ultra-pure glass or plastic threads, some literally as thin as a human hair. And instead of electricity, they transmit data as bright, laser-like pulses of pure light. Because light is the fastest thing in the universe, these cables have a massive bandwidth. We are talking up to 100 terabits per second. To put that in perspective, that is thousands of times faster than our copper friend. So, what's the deal with the good and bad parts of fiber optics? The good is just mind-blowing. It is incredibly fast, and that huge bandwidth means millions of people can stream massive data at the exact same time without a single hiccup. It can also travel thousands of miles without the signal losing any strength at all. And because it uses light instead of electricity, zero electromagnetic interference. None. But here is its kryptonite. Fiber optic cables are way more expensive to make and install. They're also super fragile. Because they're made of glass, you need a highly trained specialist to install them, and if you bend them too sharply, the glass inside will literally snap right in half. Okay, now that you know the strengths and weaknesses of both our contenders, it is time for the ultimate cable showdown. Let's put them head to head and see exactly how they stack up against each other. Think about it like a rapid-fire contrast. Copper uses electricity. Fiber uses light. Copper is slower and has lower bandwidth. Fiber is blindingly fast with massive bandwidth. Copper gets tired after a short 100-meter run. Fiber can literally run a marathon across the entire bottom of the Atlantic Ocean. Copper can get confused by electrical interference. Fiber is completely immune to it. When we map out all these features side by side, it makes total sense why we use them for completely different jobs. If you zoom in on a single house or a school building, you're going to find copper everywhere. It is absolutely perfect for cheap, flexible home networks. But when you zoom out to the whole planet, connecting massive cities and laying broadband backbones under the deep ocean, you absolutely 100% need the insane speed and distance of fiber optic cables. All right, let's see how quick you are on your feet. It's time for a quick thinking challenge. Imagine your school wants to connect a computer lab on the ground floor to a server room just one floor above it. The distance is really short, and the school obviously wants to save some money. Which cable would you choose to install? If you yelled out copper cable, you absolutely nailed it. Copper is the perfect choice for this scenario because the distance is super short, literally just up one floor in the exact same building. Copper's shorter range isn't a problem at all. Plus, it's way cheaper to buy, and the school's maintenance team can just bend it around corners to install it themselves without needing to hire some expensive glass specialist. Okay, let's totally raise the stakes. Here is your second challenge. A massive telecommunications company needs to connect two major cities that are 400 kilometers apart, and they need a high-speed data link that can handle millions of people streaming videos at the exact same time. Which cable do you choose to cross this massive distance? Boom, the answer is fiber optic. For a job this massive, copper wouldn't even stand a chance. The electric signal would die out way before it reached the other city, unless you bought a ton of expensive repeaters. Fiber optic carries those blazing fast light signals over massive distances without losing any strength, and it easily provides the huge bandwidth needed for an entire city's worth of internet traffic. So the coolest thing about this hidden network is how perfectly these two technologies actually work together. Copper brings the internet the last few feet right into your room using cheap, flexible electricity. But fiber optics, that does the heavy lifting, using incredible pulses of light to carry all that data across countries and deep under the oceans at the speed of light. From simple cables in your home to powerful connections across the globe, this is exactly how the internet stays connected. Which leaves us with a really fun, kind of crazy question to think about. If you were an astronaut tasked with building a brand new, super fast internet network for a colony on Mars, which cable would you pack in your spaceship? Would you want the cheap flexibility of copper, or would you risk packing the fragile but lightning-fast fiber optics? Think about it. Keep exploring, keep questioning, and I'll see you on the next adventure.